Hello everyone, welcome to PostgreSQL Crash Course Day 4. This is your host Mohan and I hope you are doing well. This is my WhatsApp number in case if you want to get connected and if you want to get added into the group. So let's start our day 4, and today will be probably the last day for theory, and from tomorrow onwards we will do the hands-on. That will be more exciting for you guys. So let's start our day 4. So today we will be discussing about the memory segments of PostgreSQL. In earlier videos we have discussed about the process architecture, what are the processes in PostgreSQL. We have discussed about that, and in today's video we are going to discuss memory segments of PostgreSQL. So we have shared buffers, we have WAL buffers, C-log buffers, work memory, maintenance work memory, and temp buffers. However, we have already gone through all those buffers in our previous sessions, but today we will see what are inside those. So first is the shared buffers. So, see, if you are a user or any user, if he or she wants to connect to the database, like they cannot directly read or write the data files or data, because that data should be in the memory and that should be kept in the memory before they access it. So, whatever whatever transactions are happening in the database, they are happening in the memory, and that memory area is called shared buffer in PostgreSQL. So whatever any select, insert, update, or delete operation in the data, that will be done via the shared buffer area. As I said earlier, the data block on which we want to do the operations, or user wants to do the operation, it will be first fetched from the disk, and that will be taken into the shared buffer, and operations will be performed on shared buffer itself. The data that is written or modified in this location is called the dirty data. So dirty data we have already discussed earlier, that whatever data or whatever data block which are committed but it is not still written to the disk are called the dirty data. And this dirty data is written to the data files located in the physical disk through background process, and the process name is writer process. We also call it BG writer process, and that is done when the checkpoint occurs. We have already seen that. And shared buffers are controlled by the parameter named shared underscore buffer located in the PostgreSQL.config file. So we'll discuss about this file later, and when we will do the hands-on, I will show the values inside this PostgreSQL.config file. Now the WAL buffers. So WAL means write ahead logging. So this write ahead log buffer is also called transaction log buffers. And this WAL data is the metadata information about the changes to the actual data. So WAL buffers will have all the transactions, whatever happening in the that particular data block, and if it is getting changed, and once it is committed, it will be written to the WAL buffers, and from WAL buffers it will be written to the WAL files, right? So WAL data is written to a set of physical files in the persistent location called the WAL segment or checkpoint segment. So those WAL files we can also call WAL segments, or we can also call it as checkpoint segments. So all the buffers, all the data, whatever in the WAL buffers, all the changes which has been done in the data will be written to the WAL files. And there is a process called WAL writer that is responsible for writing all those WAL buffers. So yeah, so it is written like WAL buffers are flushed from the buffer area to WAL segments by WAL writer. And WAL buffers memory allocation is controlled by the WAL buffers parameter. So this parameter also we will find in parameter file, that config file, which we have discussed sometimes back. After that, we have C log and other buffers. So what is C log? C log means commit log, and C log buffers is an area in OS RAM dedicated to hold the commit log pages. Or we can say like whatever transaction, whatever transactions are happening, and whatever the status of that transaction, whether it's a completed or committed transaction, or if it is in progress, all the information will be written in CLog buffer. And in case of crash recovery, that particular commit log buffer or CLog buffer will be referred by the PostgreSQL database engine, so that we can do roll forward or roll back as per the transaction status. And now we have the work memory. So work memory is a buffer, and it is a memory reserved for either a single short or a hash table. So basically this work mem, it will determines, or it will define the amount of memory used for internal sort or hash operation, and the default value of this work memory is 4 MB. So for example, if we increase the work memory, so it can improve the query performance. So consider we have a complex query where lot of sorting and lot of hashing is taking place. So if the work memory is less, it will, so if the work memory is very less, it will not be do that operation in the memory itself. So it will create a temporary file on the disk. So there will be more IO operations to the disk, and there will be more cost involved doing those operations. So you know that memory is always cheaper than hitting the disk, because IO subsystem in it is involved. So that's why like work memory setting is very important. So we can set this as per our workload. Next we have the maintenance work memory, and this maintenance work memory is allocated for the maintenance work. So it basically defines the maximum amount of memory used by the maintenance operation. So what can be the maintenance operations? Those can be vacuuming process, that can be creating indexes, or maybe altering the table. And the default value of this parameter is 64 MB. And again, like if we increase this value, then this maintenance, like if we increase the value of this maintenance work memory, so it will definitely speed up the maintenance operations. Now we have the temp buffers. So basically temp buffers control the amount of memory allocated for the temporary tables. So whatever temporary tables we create inside our queries, those will be created inside the temp buffers, and the default value of this temp buffer will be 8 MB. Now we have physical files, which we have already talked about. So data files, this file is used to store data. It does not contain any instructions or code to be executed. It has purely data. And this WAL files, so WAL files is write ahead log files, where all the transactions are written first before commit happens, right? So all those records will be here in the WAL files, which are committed. Uh, so as I said, like the first the records will be updated in the WAL buffers. Then it will be, before committing, it will be written in this file, and this will, after writing the transaction in those files, that will send the confirmation to the user that this operation is completed. So this is same as our log file in our SQL server. This is the log files. We have log files where all the error messages are recorded. So in our SQL server, we have error log files. It is same as log files in PostgreSQL. Then we have archive logs, and it is an optional file. Data from this WAL segments, or those WAL files, are written onto the archive log files to be used for the recovery purposes. So this archive log will be simply as .trn file in our SQL server. So this is about the archive log files. Now this is very important file, Postgres SQL.config file, because it has a lot of parameters which we will refer when we will do the hands-on. So this PostgreSQL.config file contains the parameters to help configure and manage the performance of the database server. So whatever parameters I have discussed today, all those will be listed in this file, and we go and we check, and if we want to change, we can change also those parameters. We can change also as per our requirement. InitDB installs a default copy of PostgreSQL.config and is usually location in the data directory. So what is this initDB? So initdb is basically a command which we will use to create a cluster. So when you first time you create, when you first time install this PostgreSQL data engine in your system, then there will be a default location where this PostgreSQL will be installed, and we'll have this PostgreSQL.config file over there. But if you are after that, after installing PostgreSQL, or if you want to have another cluster, then initdb command you will use. We will discuss this about in our later sessions when we'll do the hands-on. So this initdb will have the like same copy as PostgreSQL.config. So the file allows one parameter per line. So when you open this file, it will be simple kind of text file where the information is written in single lines, like there are only multiple lines. And if you read those files or that file or those lines, it will be clearly mentioned that which parameter requires a restart. It is clearly marked in the file. So when we see that, you will be able to understand it. And many parameters need a server restart to take effect. Simply in our SQL server as well, there are certain parameters which are taking effect only on restart. So here also we have certain parameters which will take effect after the restart, and we will see that those all of those in details in our further sessions. So this is it for today, and as I request every time, please go through the slides and try to do self-study to understand more. And in next video, we will install PostgreSQL in our Windows system. And after that, we will do the hands-on like creating tables, creating users, databases, and multiple things I will show over there. So that is it for today. Thank you so much. Take care. Happy weekend.